Section 8.4, Rational Functions, Day 1 for this assignment. We're going to state the asymptotes for number 1. So if you look at this function, we've got g of x equals 1 over x plus 4. If you have a function that has 1 over x, this is what it's going to look like. This is the parent function, just to give you an idea. So we can see that the parent function has a horizontal asymptote at y equals 0. Now keeping that in mind, this plus 4 here has translated that graph up 4 units. So now our asymptote is here, and the graph is going to look something like this. So for our horizontal asymptote, instead of y equals 0, which it would be without this 4, it's now going to be y equals 4 because it's been moved up. The vertical asymptote occurs wherever the denominator equals 0, wherever it cannot exist. You can't have 0 in the denominator. So that will only occur here in this case when x equals 0. Nice and simple. Now moving on to number 2. We have 6 over x plus 2 minus 3. Now, looking at the vertical asymptote, that's where the denominator equals 0. So we can say x plus 2 equals 0. Subtract 2, x equals negative 2. So our vertical asymptote is going to be at x equals negative 2, wherever the denominator only will equal 0. Our horizontal asymptote now, this does not affect the horizontal asymptote at all. It's only this portion here, the translation up or down. So this minus 3 is going to take our asymptote down 3, just like the plus 4 in this problem took it up to positive 4. Now we're brought down to negative 3. All right, the third example here, h of x equals negative 1 over x minus 5. So again, to find the vertical asymptote, that's where the denominator equals 0. So we set that equal to 0, we add 5, x equals positive 5 is going to be our vertical asymptote. That's what would make the denominator 0, and that cannot happen, which is why there's an asymptote there. Horizontal asymptote, we can see here that there's no translation. It hasn't been moved up or down. This is basically plus 0. So our horizontal asymptote is going to remain at y equals 0, just like the parent function.